This is the most expensive dirt in the solar system. A single gram of it could cost over $500,000. And right now, 30 tubes of it are sitting on Mars, trapped. How much would you pay for a handful of dirt? $10? $100? What about $11 billion? Because NASA's plan to bring it home is blowing up. Budgets are exploding, timelines are slipping, and a tiny underdog of a company, Rocket Lab, just said, "Hold my coffee, we'll do it ourselves." Imagine spending $11 billion just to bring a few ounces of dirt back from Mars. That's enough cash to buy 22,000 Lamborghinis, fund 30 blockbuster movies, or give every person in Chicago a $4,000 shopping spree. But here's the kicker. NASA's own auditors admit the real cost could hit $12.4 billion and the delivery date? 2040. Let that sink in. Your future kids would be in college by then. That's not science fiction. It's the actual projected cost of NASA's Mars sample return mission. For context, that's more than the annual GDP of some countries, all to retrieve samples that would fit in your hand. This astronomical price tag has become NASA's biggest headache in their quest to bring pieces of the red planet back to Earth. Hello, beautiful people. This is PhysxX Face. And today's story begins with Perseverance, NASA's car-sized rover that's been carefully collecting and storing rock samples on Mars since 2021. These cigar-sized rocks and dust fragments are sealed in 30 titanium tubes, waiting for their journey back to Earth. Scientists believe these samples could contain crucial information about Mars's history and potentially answer one of humanity's most profound questions. Did life ever exist beyond Earth? But there's a problem. The original plan to retrieve these samples has grown increasingly complex, expensive, and delayed. NASA's timeline now shows samples would not return until 2040, nearly 2 decades from now. As NASA Administrator Bill Nelson bluntly stated, that is unacceptable to wait that long, especially since NASA plans to send humans to Mars in that same decade. This is where our story takes an unexpected turn. In January 2025, Rocket Lab, a relatively small aerospace company compared to giants like Boeing or Lockheed Martin, publicly challenged NASA's approach. "We can wait another year, or we can get started now," the company declared, essentially telling the space agency that they had a better solution ready to go. You might wonder why Rocket Lab felt confident enough to take this stance. The answer lies in their gradual but strategic expansion into deep space missions. While most people know Rocket Lab for their Electron rocket that launches a small satellite, the company has been steadily building expertise in interplanetary missions. Their solar panels power NASA's Perseverance rover. They built the batteries for Ingenuity, the Mars helicopter that outlived its lifespan by 1000%. They're already prepping 2 satellites for NASA's 2026 Escapade Mars mission. Other than that, there are many Mars rovers, orbiters, landers, and even helicopters that already contain components built by Rocket Lab. Their confidence paid off. By October 2024, NASA officially selected Rocket Lab to develop a study for an alternative Mars sample return mission. The space agency needed fresh ideas to overcome the twin challenge of ballooning costs and extended timelines. Rocket Lab's plan is ruthless in its simplicity. Number 1. Ditch the fetch rover. Perseverance already has the samples, just drive it to the lander. Number 2. Miniaturizing everything. Use their signature small satellite tech to shrink the Mars Ascent Vehicle, MAV. Number 3. Hitch a ride. Launch components on heavier rockets, even SpaceX's Falcon 9 instead of NASA's $4 billion SLS. But the genius move, add a Mars communication satellite first. Why? Because right now NASA's rovers send data at dial-up speeds, 2 megabits per second. Rocket Lab's orbiter would act as an intermediary Wi-Fi hotspot, streaming HD videos from future missions. No more waiting days for a selfie. Scientists could guide Perseverance in real time to drop samples exactly where the lander needs them. If you have raised this far, please consider subscribing, it's free. NASA's Mars sample return is undeniably ambitious. The original concept required multiple spacecrafts performing a coordinated interplanetary ballet. A simple retrieval lander would touch down near Perseverance, collect the samples, load them into a Mars ascent vehicle, launch them to Martian orbit, transfer them to Earth return orbiter, and finally deliver them to Earth. Each component represents a technological challenge never before attempted. This complexity drove the cost of the original estimate of just under $6 billion to a staggering $11 billion. In today's fiscal environment, with NASA managing multiple priorities including Artemis moon missions and International Space Station operations, such budget overruns became untenable. The solution turned to America's innovative commercial space sector. Companies that have repeatedly demonstrated their ability to accomplish space missions at a fraction of traditional costs. You might be wondering why NASA chose Rocket Lab over larger, more established defense contractors like Northrop Grumman or Lockheed Martin for this study. The answer demonstrates how the space industry is evolving. Rocket Lab offers a unique combination of capabilities that made them exceptionally qualified for this mission. First, they have developed a vertically integrated business model. They design and manufacture nearly everything in-house, from rockets and spacecraft to critical components. This gives them unparalleled control over costs and timeline. Second, they've proven their Mars credentials. Rocket Lab built the solar panels that powered Perseverance's cruise stage spacecraft and the Ingenuity Mars helicopter. They're also deploying twin spacecraft, nicknamed Blue and Gold, for NASA's Escapade mission to Mars. This experience with Mars-bound hardware gave them the credibility that newer space companies could not match. Third, Rocket Lab has demonstrated success with complex interplanetary missions before. Their Capstone mission to the Moon and Venus Lifefinder mission showed their capabilities beyond Earth orbit, crucial experience for a Mars sample return mission. Rocket Lab's whole DNA is fail first, fix faster. When their Electron rocket exploded in 2020, they diagnosed a problem in 48 hours and launched again in 21 days. Here's the kicker. NASA didn't pick Rocket Lab. Not yet. They're paying Rocket Lab and 6 other companies just to study the problem. Rocket Lab's age, proven hardware. Photovoltaic tech that works on Mars, check. Deep space navigation from their Capstone moon mission, check. Miniaturized rockets like the 40-foot tall Neutron, perfect for Martian launch. While giants like Lockheed Martin proposed giant MAVs, Rocket Labs could fit in a pickup truck, lighter, cheaper, and less risk. Rocket Lab's proposed architecture brings several innovations while maintaining the essential elements of sample return. Their plan begins with launching a Mars telecommunication orbiter, an element not included in NASA's original plan, to support communication for the entire mission. Following this, orbiter would be an Earth-returned orbiter and a Mars entry system containing both sample retrieval lander and a Mars ascent vehicle. The lander would serve as a launch pad for the MAV, which would carry the precious sample container to Martian orbit. In orbit, the sample container would rendezvous with the Earth return orbiter, which would then transport the samples back to Earth. The samples would be protected in an Earth entry system designed to clean, contain, and safely deliver them with a planned landing in the Utah desert. This architecture streamlines NASA's original concept while maintaining its essential functions. Rocket Lab claims their approach could deliver results for a fraction of the current projected program cost and completed several years earlier than the current expected sample return date in 2040. The timeline: if NASA greenlights Rocket Lab's plan by 2026, 2028 communication orbiter launches, 2030, sample return MAV arrives on Mars. 2031, samples launch to orbit. 2033, DART lands in Utah. That's 7 years sooner than NASA's plan. $7 billion cheaper, and it all hinges on a company most people has never heard of until now. The motivation behind this complex mission goes far beyond technological achievements. These Martian samples represent potentially the most valuable scientific material ever returned to Earth. Perseverance isn't collecting random rocks. The rover landed in Jezero crater, specifically because satellite imagery showed it was once a lake bed, a potential haven for ancient microbial life. The samples come from carefully selected locations where evidence of past life might be preserved. Scientists believe these samples could revolutionize our understanding of Mars, potentially answering whether life ever existed there and providing insights into what Earth was like before life appeared. The scientific value is almost incalculable, which explains why the planetary science community has prioritized sample return since the 1980s. The story of Mars sample return is ultimately about balancing scientific ambitions with practical realities. NASA's Bill Nelson put it bluntly: the current budget environment does not allow us to pursue an $11 billion architecture, and 2040 is too long. Rocket Lab's proposal represents a potential solution to this dilemma, maintaining the scientific integrity of the mission while significantly reducing its cost and timeline. Their study, along with others NASA has commissioned, will determine the path forward for one of humanity's most ambitious scientific endeavors. If successful, this mission would mark several historic firsts: the first sample return from another planet, the first round-trip journey to Mars, and the first rocket launch from another planet. These achievements could open a few new frontiers for planetary exploration and potentially transforming our understanding of the solar system's history. The Mars sample return mission represents more than just an engineering challenge. It's a pivotal moment in humanity's exploration in space. The samples waiting on Mars could answer fundamental questions about our place in the universe and potentially reveal whether Earth is the only world to have harbored life. Rocket Lab's involvement demonstrates how commercial space companies are now taking on increasingly complex roles in space exploration. The outcome of this mission could shape planetary science for decades to come, influencing how we conduct future explorations of the solar system and potentially paving the way for human missions to Mars. As NASA and its commercial partners work to overcome the technical and financial challenges, we are witnessing the evolution of space exploration, from government-only endeavors to collaborative efforts that leverage the strength of both public agencies and private enterprise. What began as a quest to return a few ounces of Martian soil has become a testament to human ingenuity and our unyielding desire to understand our cosmic neighborhood. The final chapters of the story are yet to be written, but one thing remains clear: our journey to understand Mars, and by extension of our own origins, continue to evolve in exciting and unexpected ways. Thanks for watching. Please subscribe.